In the previous videos, we worked on these main flames of the campfire, and now we're going to finish them off. And I'll then quickly go over the other particle systems, which mostly just use the same knowledge you got from making these main flames. Now let's do the for now functionality so we don't get these thin stretched billboards when we look from above. Open the shader graph and let's start by plugging in the for now node into base color. Basically, the for now outputs values of 1 for the areas in the mesh that are pointing away from the view direction perpendicularly, and it outputs values of 0 where it's pointing directly towards the view direction. Let's save and see how it looks on our quad meshes. See how when we look from above they get wider? That's a useful functionality so we can tell Unity to make it less opaque when you look from above. Let's apply this material to a sphere instead, because that'll help to understand the for now node better. Here I'm just dragging in the fire material. As you can see, the center of the sphere points towards the camera, so it's black, but the edges point away from the camera, so they're white. From all that, we can figure out why we get this circle on our quad. You might expect the entire quad to be the same color, because it's a flat mesh, but we are looking at this in perspective, so actually each point in the quad is pointing in a slightly different direction. If we click to switch from perspective to orthographic view, then we don't get this issue, because now all the pixels in the screen belonging to the quad are pointing in the same direction. But this issue isn't a big deal, as you'll see. Let's now connect this to the alpha node instead. This gives us the opposite of what we want. We want it to be fully transparent when we look from above. So we can reverse the values that are 1 versus 0 by using a 1- node. If you don't get why this makes sense, estimate the values of a few points in the for now node and then calculate what happens when you do 1- that value. Now the lower values are when we look at it from above. So if we had plugged into alpha instead of base color, it would be more transparent from the top view. Let's now use that smooth step setup so that we have the entire quad being 100% white, and then suddenly it becomes 100% black with a short smooth transition. I'll click on the top right to make the blackboard appear so I can create a vector2 property to control this smooth step. And I'll open the graph inspector so I can set a default value. And in this case, I'll set the node to have a 3D sphere preview, otherwise we can't see any gradient because of the for now node. So now it's all 100% white, and then we do a quick transition, but it's not becoming 100% black, so I'm going to play around with the smooth step values to improve it. Remember, the first value controls the step, and the second value controls the smoothness. By the way, I found it helpful to use the base color and later switch to alpha, so I can figure out where the transition between 1 and 0 is happening. I think it would look nice if this angle is where it's transitioning between opaque and fully transparent. This seems like a good transition, so now I'll use the alpha node. Again, this seems good, so let's now try it together with all the other elements of the fire shader. To combine the for now with other opacity values, we can simply multiply. Again, if you don't understand why, you can pick a few arbitrary points, estimate their values, and manually calculate the multiplication yourself. And we're no longer getting weird thin particles at the top. Here is a final overview of the campfire effect. When a fireball touches the campfire trigger, it turns on this game object. At the top I have the audio, so I can straight away see that this doesn't just contain particle systems. You can right click here, audio source, and then drag in or select an audio. I'll leave a link to this free sound asset that I used. Then I have the point light. I just went right click and created a point light. I'll leave this as real time so it affects the player if they go near it. Click here to choose a color for it, and then place the game object where you think it looks best. Then I have the main particle system, which we've already done. Then I have the non-directional flames. We can see that their render mode is set to billboard, and they use the same shader as the main fire, but a different material instance. This is mainly because we want the fire texture to be non-directional. I made this texture in Krita the same way I made the previous fire texture. These are the material settings. I'm actually not using the demo fire shader. This is the shader I made before the tutorial, but the property names should be similar enough to understand. I'll just quickly go over the particle system. It's set to looping. The start speed ranges from 0.4 to 0.6. The start size ranges from 3 to 3.5. This will depend a lot on your texture. If your fire drawing only takes up a tiny portion and the rest is empty space, then you would need to make the start size bigger. In general, it's better for performance if you make a drawing as big as you can within the dimensions of the image. And also keep in mind, you want the image dimensions to be powers of 2. So for example, I also have flip rotation set to 0.5 so that it will randomly pick a rotation direction when I use the rotation over lifetime module. For example, if I set it to rotate at 15 degrees per second, it won't just rotate clockwise. 50% of the time it will rotate anti-clockwise. So this 0.5 means 50%. The shape is set to cone. The angle is 11 degrees and the radius is 0.3. I made it spawn within a volume, which now makes it so the length you see is no longer dictated by the speed, but by these units, which I set to 0.1. The color over lifetime is very similar, if not the same, as the main fire. If I click on the curve inside size over lifetime, we can see that it's also similar to the main fire. It doesn't have a slowing down because I want each particle to always have as much movement energy as it did at the start of its lifetime. Then I have rotation over lifetime. I clicked this arrow to give a random value between two constants. I gave it a subtle rotation ranging from 7 to 17 degrees per second. As with everything, you can experiment and see what you prefer. I wanted the fire to have as much movement as possible in as many ways as possible, and the only reason I didn't make these values higher is because you would start noticing the fire particles are spinning, and that looks weird. But these subtle values contribute nicely to the overall movement. Then I have custom data, and this is the curve I made for the dissolve. Make sure you have the correct custom vertex streams to allow the values in custom data to be read by your material. Now we have the smoke. Let me turn off this gizmo so we don't see the visualization of the shape module, just for now. This is the smoke texture I drew. For this one, I used a bunch of different brushes, but the main thing is that you have varying levels of opacity, especially at the edges. I think I also used Gaussian blur at the end as well. And remember that you want to make something quick and then test it in Unity. And it's not about how the texture itself looks, it's about how it looks in the particle system in Unity. Like the rest of the fire particles, this is set to looping, and I gave the smoke a start delay because when the fire turns on, the smoke shouldn't appear instantly, if you think about it in a real-life fire. Here is the start size, which again will depend on your texture and how big you think the smoke particles should be. This has a random start rotation between 0 and 360. I also gave it 0.5 flip rotation, just like with the non-directional fire particles, and I set its rotation over lifetime to be a random number between 11 and 33 degrees per second. I made the start color be random between these two colors. The darker one is 70% opaque, but remember your color will probably be different because of your lighting and post-processing and environment. This is the gradient for color over lifetime. The most important thing here, I would say, is that the particles start faded out, and around here they achieve their maximum opacity, which is about 50% opaque. Then they start fading out to 0 again. Also, the colors change a lot, but you could probably get away with just having the start color and the end color that's darker than the start color. For the colors, I followed a similar principle that I did for the actual flames, of making it start off more yellow, then become more red. I decided to change how the speed and velocity of the smoke works, so that it's simpler to explain. I changed the start speed to be 0 in the main module, and I changed the velocity over lifetime module to use curves for the x, y, and z. Also, the speed modifier is a range between 0.7 and 0.9. The speed modifier is simply a value that multiplies the velocity of a particle. For instance, if the particle's overall velocity at a particular moment in time would be negative 2.5 in the z direction, then instead it will be a random number between negative 1.75 and negative 2.25, because 0.7 times negative 2.5 is negative 1.75, and 0.9 times negative 2.5 is negative 2.25. Here is a good example of me not being careful to make sure that Unity didn't mysteriously rotate an object to negative 90 degrees. I used the z-curve to control the vertical movement of the smoke, and it starts off going upwards fast and then slows down at the end of its lifetime. But the vertical axis is usually the y-axis, and if we investigate, we see actually the parent particle system is set to negative 90 degrees in the x-axis. So that's why this unexpected thing happens. Anyway, I clicked here to set these to be curves, and I set the x velocity to be a linear curve that starts off at around negative 1 and ends at negative 4. This makes the particle start moving sideways slower in the negative direction and then gradually becomes faster in the negative direction. Because this is a curve for velocity of the particles, not their position, then a linear curve will achieve an easing effect. I'm only saying this for those of you who have done animations where you animate the position of an object, not its velocity, and you ended up using a curve that's not linear, maybe something similar to this. If this were a curve for the position, the object starts off moving slowly away from its original position of negative 0.4, but then gradually becomes faster. To illustrate that, from here to here, it only traveled a distance of about 1 unit, but from here to here, it traveled a distance of about 2.5 units. And I made it have 0 y velocity. And I set the particles to start off faster in the positive z direction with a velocity of 2, but then quickly lose speed to become 0 at the end of their lifetime. A curve like this won't do because I want particles to slow down more quickly than this while still having a bit of velocity. So you can double click to add a point and then adjust the slope by turning this handle here. This is to give it a similar movement to the Zelda fire that I showed previously. Then I have size over lifetime. I went with this curve, but you might want to experiment making the fire noticeably smaller at the end of its lifetime, or just always getting bigger and bigger as it dissipates into the air. Then I have custom data, and I just used the first value because I just want the smoke to dissolve. I don't actually give it distortion. The sort mode is set to youngest in front, so the newer particles appear in front of the older particles. The max particle size is set to 2. If you make it a small size, then if you zoom in on the screen, the particles stay small. You can try this out, set it to 0.1 and then zoom in so you can see. Make sure the order in layer makes sense. I wanted the smoke to be behind the flames, so I gave it a smaller value of order in layer compared to the particle system of the flames. And this is the smoke material. Again, it's using the same shader as the fire particles. Lastly, I have the embers. You can look here at the values I picked to help you decide on your own. And I made the start color set to random color, so each particle will have a random start color within this gradient. Let me turn off the point light so you can see it better. I made it have bursts with different probabilities, just so there will be more variation. So this particle system has a duration of 2 seconds, which means every 2 seconds there is an 80% chance of having a burst of 2 particles, and 0.2 seconds after that there is a 50% chance of having a burst of 2 particles. I also have rate over time for a regular stream of 6 particles per second. Here is the shape module. For velocity over lifetime, I have a curve similar to the smoke curve. I made it fade out at the end of its lifetime, and it also becomes darker. This is the size over lifetime. It starts small, then becomes big, then goes back to being small at the end of its lifetime. I also gave the movement some random noise. You can play around to see how these values affect the movement of the particles, but what I did was simple. I just set the strength to range from 0 to 0.6 and the frequency to be 0.5. I forgot to turn off custom data. I made this particle system by duplicating the smoke particles, and then I just forgot to turn it off. This here is the material. It uses a default Unity shader. I've looked into this and I haven't found anything helpful about it, so I just click Apply to Systems. Usually this makes no noticeable difference, but if I remember correctly, there have been a couple of times where the particle wasn't showing up until I clicked Apply to Systems. I created the material by right-clicking on the project window and selecting Create Material. Then I selected the standard unlit shader for particles, and I changed the rendering mode to fade. The two other ones I use the most are cutout and additive. Cutout is the best of the three for performance, but doesn't allow for soft edges in particles. And additive makes the particles closer to white when they overlap something, including each other, which is useful for things like spark effects. Click the tiny circle with a dot to select a texture, or drag a texture into the square. In conclusion, fire, shader graph, particle systems, etc. Thank you. Alright, so that's it for the campfire. The next video would be this fireball, but I was thinking of maybe doing this other one instead, which is from this game that I made for the GMTK Game Jam, and I've since edited the game. So yeah, I still haven't decided yet, but let me know if you have a preference.